Okay, so hello and welcome back to another Unity multiplayer tutorial. Today we're going to be working on part 3 of the character select tutorial. So now that we can go into a lobby, select our characters and see everything, we want a way to start the match, and then once you go into the match we need to spawn in the characters that you selected in the previous scene. If you end up enjoying this tutorial or find it useful, it'd be greatly appreciated if you could leave a like and subscribe if you haven't already, but without further ado, let's get started. So as always, there'll be a link at the top of the description and that will take you to our GitHub repository if you want to go and download the project for yourself. So now we can head into Unity and we're going to need a way to store data between scenes because we select our characters in the character select scene, but then we're going to want that to also be readable when we change scenes, and normally when you change scenes everything gets destroyed, so we'll need some persistent object for this. So what I've gone ahead and done is I've made a game object called the server manager, and I've made the server manager script, and this is currently empty, so you just need to make a blank script and we can open that up in VS Code. So now we're in VS Code, we're going to want to make this script a singleton, where we can have one instance of this always existing in our game that we can access wherever we need to. So the way we do that is we have a public static and then instance of this class, so server manager, and we'll just call it instance. And we'll make sure we can get it publicly, but only set it privately. So we'll make that property. And then in our awake method, private void awake. So when this object starts existing in our scene, let's hide the side panel. We can say if the instance does not equal null. So if there's already an instance of this singleton in the scene, or, and it's not us, so instance does not equal this, then we want to destroy this game object, and that will just make sure that this does not ever exist twice. And then we want to say else. So in this case, we want to set the instance equal to us, so this, and we want to make sure this object doesn't get destroyed when we change scenes. So don't destroy on upload this game object. And now that we've made this, we can go anywhere in any of our scripts and say server manager.instance, and then we can do whatever we want inside of this once we make other methods. So now we've set that up, we're going to want a way to start the host or start the server through here. Because normally, if we go back to our main menu script, we just say start host, start server, but we're going to need a bit more than that, and it makes sense to put it in our server manager rather than in our main menu code. So what we'll do in here is we'll make two methods, public void start server, and then we'll make public void start host. So now we've made these methods, we still need to call the same methods that we call in the main menu. So in here we want to say network manager.singleton.startHost, and in the other one the same but for start server. So network manager.singleton.startServer. And then we need to subscribe to some events. So we want to know when someone joins the server. So the way we can do that is using a method called, an event called connection approval callback. So network manager.singleton.connection approval callback. And we'll make a method called approval check. And what this will do is every single time someone tries to join the server will execute this method, and we can do stuff like checking, is the server full? If so, don't let them connect. Or we can take in data from them and store it in a list, or we can do whatever we want. We can decide where to spawn them in our world whenever they connect. It's just a method for when that happens. And so if we make the method down here, private void approval check, it takes in two parameters, network manager.connection approval requests called request, and network manager dot connection approval response. This is how they do it in the documentation. So inside of here, when someone connects, we want to add them to a list or a dictionary of all the players that are on our server, and for that we'll need a custom data type to store. So I've made a class called client data, and then inside of here we'll need to add the properties. So for us, we want to add the ID of the client, so public ulong client ID, and for the sake of this we just need their character ID that they've selected, so public int character ID. Now when they connect to the server they haven't selected a character yet, so we'll just default that to -1, and in our constructor client data we won't make the character ID be something they need to pass in, because when we add them to the server, like I said, they won't have a character yet. So we'll just take in their client ID, if I can spell that right, ulong client ID. And we'll just set this .client ID equal to the one coming in. And we also need to make sure we add the serializable tag in case we ever need to send this over the network, because the client, when they connect to the server, might want to pass through some extra data in here, like their name. If we get the players to select their name, that would come through here, and we need to serialize it over the network. So technically, at the moment, we don't need this here, but we will probably come back and add to it, and so it's better to have that just in case. So now we've got that custom type, we can go and make a dictionary for it, which we can store all of the players' data that are on the server. So public dictionary, where the key, the lookup value, is going to be their ID, and then the value is their client data that has all their information. And that also does have their ID in as well, but I think it makes sense to keep that in there as well. So technically it's in two places, but I think it's completely fine for this. We'll call it client data. We'll also make that a get private set, because we want to read this in our player spawner later on. One other thing we can add while we're up here is we can make a private bool called something like game has started. And then what we can do with that is we can make it so once the game has started, players can no longer join even if we're not at max capacity. So in our approval check, we can do a check at the start saying, well, if client data.count, if that is greater than or equal to 4, then we're at max capacity. Or if the game has started, then we want to say response.approved equals false. We have not approved this person, and we will stop there. So we're going to reject anyone trying to connect when we're at max capacity or when the game has started. Otherwise, after this, we can say this person will be approved, we'll let them connect. So equals true. We can also set on response create player object equals false. We don't want that to happen automatically. We want to manually spawn in their players. And then response.pending equals false, because we are now done. We don't need to do anything else here. That is this method done. Actually, it's done besides one final thing, which is to actually add this player to the list, to the dictionary. So client data, and then in here, we need to pass in their ID. So request.client network ID. So the person connecting, we can read their ID, we can add them to the dictionary. With dictionaries, you don't have to call .add. By doing this, it will automatically add if they're not already in there, and if they are, then it will just update them. So this equals new client data, passing in request.client network ID. So now they are a player in our list. So now we're done with the approval check. Let's make sure we subscribe to it in both our host and server methods. And then there's another method we like to subscribe to know when the server is ready to go. So network manager.singleton.onServer started, and we can subscribe that, make a method called like on network ready, and do that in both. So we'll make a method private void on network ready. So once the server is ready here, we want to change scene to the character selection scene. So let's go grab that code out of our main menu script. So in here now, we don't do this anymore. So I'm going to cut out the scene changing line, and I'm going to change these two lines to the methods we've made. So it's going to be server manager.instance.start host. Swap that over, and then server manager.instance.start server. And we can go put the scene change here. We're going to also need to bring across the name of the scene. So let's take those across. So now the main menu is very simple. We can take out scene management. We don't do that in here anymore. And then we're going to need two scene names, because we're going to need the character selection and then the actual game. So at the top, we can do this. We can say gameplay scene name is gameplay. And we'll also add character select scene name is character select. So down here, we actually want to go to the character select scene. And we also want to know when someone leaves, because if someone leaves, we need to remove them from our dictionary. So we'll say network manager.singleton.onClientDisconnect callback. So when someone disconnects, call the method onClientDisconnect. And so we'll make that private void onClientDisconnect, taking in the ID of the person who disconnected. And we'll just say if they're in our dictionary, remove them. So if client data dot contains key, which it should, but it's better to make sure just in case. Then we'll say if client data dot remove client ID. This will then return true if they are successfully removed. So we can say debug.log, something like removed client and then client ID. And we can even take this debug log and go put it in the approval check at the end saying added client request dot client network ID. So what else do we have to do? Well, we need to initialize this dictionary whenever we start. Now we could initialize it here, but it would mean that if we left the server and then started it up again, this would not actually be reset and we'd still have all the lingering data. So we want to do this whenever we start. So for example, over here, just before we start host and start server, we'll say client data equals new dictionary of long client data. And it's the same for both. We could even make another method here that does these first 3 lines for us since we're technically just copying them here, but this will be fine for now. It's not too much. So now there's just 2 more methods we want to make in here. The first one, we're going to want a way for our character selection code to say, hey, server manager, this client is going to be this player. We need a way to set that. So we're going to say, hey, public void set character. And that'll take in the client ID of the client that's selecting the character. So client ID. And then the int character ID, like so. And then all we need to do is say if client data dot try get value. So if we can find in our list, in our dictionary of clients, this client, then it will pass us out client data data. And then we can set data dot character ID to be the character ID coming in. So now we have a nice public method we can call here from the character selection script to set a character's ID. And the final method in here will also be called by the character selection script, public void start game. And in our case, we're just going to start the game once all the players in the lobby have readied up. So we'll say here, game has started equals true, so people can no longer connect. And network manager dot singleton dot scene manager. Want to load the scene, gameplay scene. Load scene mode dot single. So that's it for the server manager. And this kind of script will exist in every multiplayer game. You'll need your own way to handle connections, disconnections, and everything. And we aren't handling every single event here possible. But as you would work on your game and expand, you would start listening to more events. So this isn't a fully fleshed out thing. It's just the bare minimum for what we need for this project. And now we can go to the character selection over here. And in the lock-in server RPC, once we've locked in a player, we can then do a check and we can say, go through, so for each var player in players, go through every player and check, is this player locked in? So if not player is locked in, then return. If any of the players aren't locked in, then we don't want to run any more code. But if everybody is locked in, then we can go through every player again, var player in players. So only once they're all locked in, we'll then say, server manager dot instance dot set character, and it's this player's client ID and this player's character ID. So we're now setting all of that data. And then finally, server manager dot instance dot start game, and that will run the method we just made. That will send them to the gameplay scene. And then for the sake of this tutorial, all we want to do is spawn in the characters they selected to prove that we can then pass that data around. And then from there, you can make your own actual character movement, abilities, set up the cameras, all that extra stuff can come later. But for now, we're going to go to the character data script. So in here, we're adding one more field, the network object here, call it gameplay prefab. And this will be the one that actually has all the code on that controls the character. And it needs to be a network object so we can spawn it over the network. And then make a getter for that. And then we'll have a script called the character spawner, which I've currently got empty. This will be in our gameplay scene. And in here, we're going to need to say override network spawn. So this method is called as soon as this object starts existing, and we can then say if is not server, return. And I meant as soon as it starts existing on the network. So only the server should run this code, so if we're not, then return. And all we want it to do is go through every client and spawn in their characters. So we'll say for each var client in server manager dot instance dot client data. So go through the dictionary and say var character. We need to load their character, which means we'll need the character database. So we'll add serialized field private character database like so. We'll say equals character database dot get character by ID. We've already made that. And we'll just pass in this client's dot value because we're in a dictionary dot character ID. So load their character. And then if that character is not null, just to be safe, we'll just do that check. If not null, then we want to say instantiate character dot gameplay prefab. And this is the point in the code where if you had spawn points, you would grab those spawn point positions and set the character to spawn there. For this, we'll just make sure they're not all stacked on top of each other. So we can make a var spawn pos equals new vector 3. And I'll just do something like random.range between -3 and 3. And then the y I'll keep as 0. And then the z can also be random.range between -3 and 3. And then we'll say spawn this person in at spawn pos, and the rotation doesn't matter, so we'll just set it to quaternion.identity, which is the default rotation. And as this currently is, it would only spawn it in on the server, but we want everyone to see this, so var character instance equals this. And then with that, we can say character instance, and that is a network object. And on network object, you can say spawn as player object. And if you then pass in the ID of the player who owns this, this then belongs to them. So everyone will see the character, and that client has authority, meaning if you wrote movement code, that player would be allowed to move this character. So client.value.client ID. And that is it for all of the coding. So just a quick rundown here again. Make sure it is the server doing this code. The server will then go through all the connected clients. We'll then say get the character for them, and as long as we can get it, pick a random position within this range, and then spawn in that character there, and then make sure the client who it belongs to is the owner of that object. Then back in our other script, in the character display, we just make sure once someone locks in, if everybody is locked in, set all their characters into the server manager and then start the game, which changes the scene. And that's basically it. So now we can go back to Unity and make sure everything is set up in here. So you'll have to make sure that the names on the server manager, the scene names, character select, and then gameplay, and then make sure your actual scenes are character select and gameplay. Make sure they are in the build settings so that if you build, you can actually change scene. And then on our network manager, I've added the network prefabs here. Because we're spawning them over the network, they need to be in this list. So for every character, I've made a prefab, which is just their FBX model as a variant. And then I've just added the network object component like this. That's all I've done. So as you can see here, I have mutant, which is just the mutant with the network object on. And I've done that for all the characters, and I've set it as each character's gameplay prefab. And then also on the network manager, if I look down here, I've enabled connection approval. If you don't do this, you'll get an error immediately saying you need to enable connection approval because we try using it in our code. And then what else have we got? The server manager exists, that's all you need. And in the gameplay scene, the character spawner exists. And you need to assign the character database so it can actually look up that data. And I think that should be everything. So if we go back to the main menu, File, Build and Run, we can now do a test. Okay, so I've got 4 builds running. I'm going to host and join as free clients. I'm going to simply just pick different characters here and then lock everyone in. And when I lock in on the final client, it should send everybody to the gameplay scene. So I'll hit lock in. Everyone changes scene and all the characters are now spawned in. Everyone sees this, and because they are assigned to our client ID, a proof of this is that if I leave on one of these clients, this one is on Michelle at the bottom left. So if I leave as her, she leaves from all of the other people's games. So yeah, that's it for this tutorial. We now have the ability to start a match and spawn in characters that belong to each of the clients. Be sure to let me know down below if you want to see more of this series or if you'd rather me cover something else. I'm thinking that this is probably enough for this series. Otherwise, we'd then go on into how to do like abilities and movement and everything, which would probably make sense to be separate from this, but we could also incorporate it into the series and keep it going. Just let me know down below what kind of tutorials you're wanting to see for multiplayer. So I hope you enjoyed this tutorial and found it useful. If you did, then please leave a like and subscribe. It would help a lot. That's it for now, and I'll see you in the next one. Goodbye. But of course, before I go, I've got to thank my patrons. A special thanks to Ryan Shu, Gregory Pierce, Mark McCorkle, Sahila, Dario Alvarez, Francisco, and David McDermott. If anyone else would like to help support the channel monetarily, the link to our Patreon is down below. If not, there are also links down below to other social media such as Twitch, Twitter, and Discord. If you could help us out by following on any of those or checking any of those out, that would be greatly appreciated. Thanks again for watching, and I'll see you in the next one. Goodbye.